Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll learn to determine the range, the interquartile range, variance and standard deviation, okay, as a measure to describe the dispersion. So we have learned about this. Range is the largest value minus the smallest value. Let's go through example 3 together. So given a set of data 34, 23, 14, 26, 40, 25, 20. Determine the range of this set of data. So this is the smallest value, then this is the largest value. So 40 minus 14 gives us 26, which is the range, okay? So how do you determine the range from the frequency table? This is a frequency table, okay? So the table below shows the scores obtained by a group of pupils in a chemistry test. So the scores are scattered from 2 to 8, okay? So the range is 8 minus 2, which is 6. So how do you determine the interquartile range of a set of group data? So just now we have learned about range. Now we will learn interquartile range. When the values of a set of data are arranged in ascending order, okay, we'll first arrange the data in ascending order. This is very important, okay? The first quartile, Q1, is the value of the data that is at the 1/4 position. And while the third quartile, Q3, is the value of the data that is at the 3/4 position. Okay, later on, we'll look at examples so that you can understand better, okay? So, first step, arrange in ascending order. Second step, determine the median. Third step, divide the set of data into two parts, the part of data before the median and the part of data after the median. Then fourth step, Q1 is the value of the data in the middle position of the part of data before the median, and Q3 is the value of data in the middle position of part of the data after the median. Then the sixth step, if the number of data is odd, the median, Q1 and Q3 can be identified directly from the data. But if the number of data is even, the median, Q1 and Q3 can be obtained by finding the average of the two values in the middle position. Okay, so interquartile range will be Q3 minus Q1. Let's go through example 5 together, okay, so that we can apply what is learned here. So, part A, determine the interquartile range of each of the following sets of data. So, we can see that it is already arranged in ascending order. So we can see 13 is in the middle, so this is the median. Then this is the front part before the median, this is after the median. So the middle position will be Q1, and after the median, the middle position will be Q3. So the interquartile range is 20 minus 6, which is 14. Then part B, 11, 14, 14, 17, 19. Okay, we also can see that part B is also arranged in ascending order already. 19 is in the middle, so this is the median. So now the front part, the middle position is 14. Okay, so Q1 is 14. Then after the median, the middle position is 20 and 21. So Q3 will be 20 plus 21 divided by 2. So we get 20.5. Okay. So the interquartile range will be 20.5 minus 14, which is 6.5, okay? Then part C. Again, we can see that it is arranged in ascending order already. And the middle one is here, okay? So we can see that the number of data is 8. It is in even number. So the median will need to take the middle position divided by 2. So the median is 2.7. So the set of data in front the median will be here, and the middle position is here, okay? So Q1 is 2.5, then Q3 is the average of 2.9 and 3.0, which is 2.9 plus 3.0 divided by 2 equals to 2.95, okay? So this is Q3. 2.95 minus 2.5 give us 0.45, so this is the interquartile range, okay? Then example 6. Determine the interquartile range of the following frequency table. So now, we will need to find the cumulative frequency, okay? So, first of all, for score 2, there are 3 of them. Then for score 3, there are 5 of them. So we'll add up 3 plus 5 here, 8. Then for score 4, we will add up these 6 together, which is 14. Okay, then now we'll add this 8, which is 22, then add 12, which is 34, then add 7, we get 41, then add 3, we get 44. Okay, this is how we came to here. So now the first quartile will be the 1/4 times 44th value, because now we have 44 data. Okay, so we can see is the 11th value. So the first quartile is here, because here is 8, here is 14. Okay, how do we interpret this value 8? It means that there are 8 of them with scores 3 or less. Okay, so we know that the 11th value is situated here, so Q1 equals to 4. Okay, then Q3 is the 3/4 times 44th value, which is the 33rd value, so we know it is situated here. So third quartile is 6, interquartile range is 6 minus 4, which is 2. Okay, what do you understand about variance and standard deviation? Variance and standard deviation are the measures of dispersion commonly used in statistics. Okay, the variance is the average of the square of the difference between each data and the mean, whereas the standard deviation is the square root of the variance, which also measures the dispersion of a data set relative to its mean. Okay, so all these are the formulas. These two are formula for variance, then standard deviation will be square root of them. Okay, so let us go through some examples so that you can understand better. So now, example 7, determine the variance of the set of data 2, 4, 5, 5, 6. So let us look at this, my memory. Okay, the mean is sum x divided by n. So all these are the x values. So sum x will add up all the x values, then divide by how many of them? There are 5 of them. So now mean equals to 4.4. Then variance. So let us refer to this formula. Okay, sum of x minus mean square. So this is what we are doing over here. X is 2, right? Then minus mean is 4.4. Then whole thing square. Okay, then again x minus mean, x now is 4, then the mean is 4.4. Okay, then whole thing square. So we add up everything and then we divide by 5. This will be the variance. Okay, then we have another alternative method for variance. You can sum up all the squares of the x values first, then divide by how many of them? So 5 of them. Then only minus mean square. Okay, it is the same. We'll reach the same answer also. So now let us go through example 8. Okay, so determine the standard deviation of the set of data. So first of all, we'll find the mean first. Sum x divided by n. So we add up everything and divide by 10 of them. There are 10 of them. Okay, so the mean is 11.8. Then now variance will be the square of them will sum up and then divide by how many of them? 10 of them, and minus the mean square. So we'll reach the variance. Okay, 21.56. And the standard deviation is square root of the variance, which is 4.643. Then now let us go through example 9 together. The table below shows the number of books read by a group of pupils in a particular month. So calculate the variance and standard deviation for the number of books read. So first of all, every time I'll find the mean first. Let us refer to this info zone. Okay, mean is sum of fx divided by sum of f. So all these are the frequencies. Okay, so sum f will be here. Sum f equals to 3 plus 5 plus 8 plus 2 plus 2. So we get 20. Okay, so now all these are the x values. So first of all, we'll need to find fx. So we can see 3 times 0, which is f times x. Okay, plus 5 times 1, then plus 8 times 2. Okay, this is how we reach here. Then divide by sum f. Okay, so we have applied this formula. to find the mean. Then now variance. There are two formulas that you can use, either this or this, will reach the same answer also. So in this case, here they have used the first formula, okay? So the summation of f, okay, frequency. So 3 times 0 minus the mean, then whole thing square, plus the frequency, which is 5, times 1 minus the mean, then whole thing square, okay? We add up all these. And then we divide by sum f, so we'll reach the variance, okay? Or you can use the alternative method also, okay? So just now I've said this is the x values, then these are all the frequencies. So we will create two more columns here, okay? For x squared and fx squared. So x squared will be 0 square in this case, 1 square here, 2 square here, 3 square here, and 4 square here, okay? Then fx squared will be this times this times this, okay? Which is 5, then 8 times 4, which is 32, okay? Then we add up all this, we get sum of fx squared equals to 87, okay? So if we apply the formula, so we get 87 divided by sum f, which is 20, minus mean square. Mean is 1.75 square, okay? So we'll get the same answer also, 1.2875, okay? So for the standard deviation, it will be the square root of 1.2875, okay? So I know now you guys may feel a bit confusing, but if you go through this homework and do more practice, the knowledge that we learned today will belong to you, okay? So go back, you'll complete this self-practice 8.2a. If you guys are having a lot of difficulty, you are having a lot of challenges in completing all this homework, I've prepared an online course for you guys, okay? It is a step-by-step guideline in helping you guys to complete all this homework in the textbook, including the comprehensive practice at the back of each chapter, okay? So coming next, we'll learn to explain the advantages and disadvantages of various measures of dispersion, okay? To describe and ungroup data. So do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos, okay? I'll see you in the next video. Bye bye.